Have you ever imagined how streaming platforms like Netflix or IMDb decide which movies to show you at the top? Think about it. A movie can have multiple ratings, an IMDb score, Rotten Tomatoes percentage, user reviews. But how do we combine all these different lists to find the best overall movies? That's where Fagin's algorithm comes in. It is a powerful method in databases and search engines to efficiently find the top key results, where data comes from multiple rank lists. Instead of scanning every single record, it smartly accesses only a small portion of each list, saving both time and computation, and still gives us the top performers accurately. Now, this Fagin's algorithm is divided into two phases, rather, works in two phases. So the phase one is the sorted access. We start reading each list in parallel from the top. As we go down, we record the movies we encounter. Once the movie has appeared in all the lists, at least once, we add it to our scene list. We keep going until we have seen K movies in all the lists. Then is the phase 2, which is the random access. Now, for those scene movies, we might be missing some scores. Maybe we saw a movie in IMDb and Rotten Tomatoes percentage, but not yet in the user list. So we perform random access to fill those scores, like total or average, for each movie and pick the top K results. This method avoids scanning unnecessary entries and drastically reduces computation time. Now, to make this crystal clear, let's take a real world example with movies and see how Fagin's algorithm helps us find the top 3 picks based on IMDb ratings, Rotten Tomatoes percentage, and user ratings combined. Now, we have taken 3 lists. First is the IMDb rating, second is the Rotten Tomatoes, and third is the user ratings. In these 3, there are 5 different movies with different ratings. For IMDb, for example, A has 9, B has 8.7, and C 8.3, etc. Similarly for Rotten Tomatoes and user ratings. So, first is the sorted access. Here we start reading all the 3 lists in parallel from the top. So round by round, we see A, C, and B. So the scene list will contain A, B, and C. In the second round, we get B, D, and A. So the scene list will contain now A, B, C, and D is added. After that, we get C, A, and D. So the scene list remains AC, A, B, C, and D. So we see after 3 rounds, the scene list is like A, B, C, and D. We continue until we have seen K movies that appear in all the lists. So here are 5 iterations. So after we have seen those 5 iterations, we see that A, B, C, these 3 lead the scene list. This means we have probably seen enough data from the top to guess who the top contenders are. Now for those scene movies, A, B, C, D, we might not have all those scores. For example, maybe we saw movie A in IMDb and Rotten Tomatoes, but not yet in user ratings. So we perform random access to get the missing values for those few movies. As you can see, we have 5 movies A, B, C, D, E, and each list ranks them differently. So as you can see, A gives A has got 9.0 rating in IMDb rating and 90 in Rotten Tomatoes percentage, 9.2 in user ratings. So the total is 108.2. Similarly for B, it is 83.2, C is 111.8, etc. Now, if we take the total scores and check it with the scene list, then we get that C is in the top of the ranking list because it has got 111.8 as the total score, and D and A as the second and third ranking in the list. So, why does Fagin algorithm matters? Fagin's algorithm is used in search engines, recommendation systems, and database queries, where data comes from multiple sources, like ranking web pages by relevance, popularity, and freshness. It also has the foundation for more advanced algorithms like the threshold algorithm, which improves efficiency even further. So the next time you get the list of top K movies or best restaurants near you, remember, behind that list is a Fagin's algorithm doing its magic.